All right. Hey, so today we are starting notes in our new packet about probability and data displays. So we're going to start today with talking about some probability basics and stuff like that. And then tomorrow it'll be all about different kinds of independent and dependent events and stuff like that. But let's start with just the simple stuff. We're going to start with sample spaces. So go ahead and flip in your packets with notes to the first day of notes. So we're looking for notes day one, probability, sample spaces, independent versus dependent events, that sort of thing. Okay, so first off, thing we need to know is what is a sample space? So basically what we're looking for in a sample space is what is the list of possible outcomes? What are the things that could happen? What are all the possible events? So basically we want the list of possible outcomes. All right. So sometimes we'll also want like the number of possible outcomes. We'll get to that eventually. But the number of possible outcomes is also kind of the sample space here, or the number of things in your sample space, basically. So number of things in your sample space. Okay. So for our first example, we're just going to think up kind of a random event. I'm going to go with a marble is pulled from a bag. Containing one red, 3 green, and 2 blue marbles. What is the sample space? That's kind of what we're asking ourselves here. So the sample space are all those marbles, kind of a list of all the different colors of marbles you could pull out. So our sample space, and one way to express a sample space is to just kind of use a list and with like little curvy brackets and stuff like that. So I'm going to list the marbles and use like R for red, G for green, B for blue, stuff like that. Since there's one red, we would have one R in our sample space. And then there's 3 green, so I'm going to put 3 Gs. And then there's 2 blue, so we're going to put 2 Bs. That is one way to express your sample space. Sometimes they'll do like a little tree of possibilities. You could also put for your sample space R, G, 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 B, B, and have them like all connected like a little tree diagram like that. That would also count as a way to express your sample space. And then for the number of outcomes, there are 6 marbles in the bag. There are 6 things in our sample space. So our number of possible outcomes is 6. All right. So go ahead, pause the video, or actually don't pause the video, just kidding. We got to write down the problem first. You're going to try one next though, on your own. So this time, let's say you're picking a card. A card is chosen from this deck. Now it's going to be kind of a special deck of cards. This deck is going to have 8 cards in it. And they're going to be cards numbered 1, 2, 3, 7, 2, 1, 8, 7. All right, there's all your cards. So we want to know what is your sample space, and then what are the number of possible outcomes. So now pause the video real quick, see if you can figure it out, then hit play again, and we'll talk about it. All right, hopefully you did that. Your sample space, most of the time you want to line up your sample space in order from, smallest to largest and things like that. So our sample space we had 2 1s. We had 1, 2, 2 2s, 1 3, 2 7s, and an 8. And then for our number of possible outcomes, there were 8 cards, so 8 possible outcomes. All right. So hopefully that makes sense with sample spaces and stuff like that. The next thing we're going to start talking about is probability. So in probability, you use sample spaces because you need to know the number of possible outcomes in order to determine probability. There's 2 kinds of probability we're going to talk about today. The first kind is theoretical probability. Now, theoretical probability is the probability that's calculated based on a theory. It's usually the number of favorable outcomes, or the outcomes you're looking for, divided by the number of possible outcomes, which is what we were just finding. So let's write that down. It is the calculated probability based on a theory. And usually it's the number of favorable outcomes over the number of total outcomes. Number of favorable outcomes over the number of total outcomes. So that's what we're looking for there. Let's try this with that same marble problem. So let's go back to that bag of marbles. So from up above, a marble is pulled from a bag containing 1 red, 3 green, and 2 blue. So we're going to use the same bag of marbles down here. And we want to know, what is the probability that the marble we pick, chosen marble, is green. Okay. So now we need to ask ourselves, what are the favorable outcomes? Well, we want to pick a green marble in this scenario. So since there's 3 green marbles, 3 is the top number. And probability is usually written as a fraction, sometimes a percentage, but we'll get there. So there's 3 green marbles. How many total outcomes were there? Well, our number of total outcomes in the marble bag was 6 because there's 6 marbles. So 3 green over 6 total is the fraction 3 over 6. But when we have fractions that can reduce nicely, we should reduce them. These are both divisible by 3. 3 over 6 is the same as saying 1/2. Because 3 divided by 3 is 1. 6 divided by 3 is 2. So our probability is 1/2, or 1 out of 2. If we were going to turn this into a percentage, if you didn't know, 1/2 is also known as 50%. The other way you could figure out the percentage is you could divide in your calculator. You could do 1 divided by 2 and then multiply by 100. That's 100%. Or you could divide 1 divided by 2 and then move the decimal over 2 places. That will also get you your percentage. Okay. So let's try another one. This time, we're going to go back to that card scenario. So we're going to choose a card from this deck. And actually, let's redraw our card deck really quick down here. We had 8 cards. One, two, three, 7, 2, 1, 8, and 7 were our cards. And we want to know this time, let's do the probability that it is a 1 or an even number. We want probability that we pick a 1 or an even number. Okay. A 1 or an even number. All right. If you want to pause it really quick and give it a try, you can. And then hit play again, and we will talk about it together. If you're kind of confused, feel free to just let it keep going, and we'll talk about it. All right. Hopefully you gave it a try. The first thing we need to think about is our favorable outcomes. So we want to know what the probability is that it's either a 1 or an even number. So we need to count up how many 1s are there, how many even numbers are there. So first off, there's 1, 2 1s, and then we need to look for the even numbers. There are 1, 2, 3 even numbers. Okay, so let's see, that's a total of 5 favorable outcomes. And how many total cards were there? There were 8 cards, right? 5 over 8. And the nice thing is 5 over 8 doesn't reduce as a fraction, so we can leave it as 5 over 8 if we want to. If we were asked for the decimal version of this, here's what we would do in the calculator, or the decimal, or the percent version of this. Here's what we would do. I would go 5 divided by 8, and we get 0.625. You can either think about, just moving the decimal 2 places to the right, or you can go times 100, which gives us 62.5, which is the percentage that we're looking for here. That's the same as 62.5%. All right, so that's theoretical probability. Number of favorable outcomes over number of total outcomes. That's probably the kind of probability that you're a little bit more familiar with. The next kind that we're going to talk about is experimental probability. Okay, so experimental probability is probability based on a series of experiments. So probability based on a series of experiments, or based on kind of data you already have, kind of assuming that data is going to continue, that a trend is going to continue. All right, so some examples of experimental probability. Let's say you were flipping a coin a whole bunch of times and seeing if it's heads or tails. Let's say 3 of the last 12 coin flips have landed on tails. What is the experimental probability of tails, of getting, or of landing on tails? What is the experimental probability of tails? All right, well, it's hopefully pretty simple, right? 3 of the last 12 have landed on tails, so 3 over 12 is our experimental probability. 3 tails, 12 total. That's 3 over 12. Now, the nice thing is 3 over 12 does reduce as a fraction. So 3 over 12 is the same thing as saying 1/4, because 3 divided by 3 is 1, 12 divided by 3 is 4. If you divide them both by 3, we get 1/4. All right, and 1/4 is also known as 25%. All right, what if a follow-up question asked, what's the experimental probability of heads? All right, well, if 3 out of the last 12 landed on tails, how many landed on heads? Well, it must be 12 minus 3, right? Which is 9. That means that 9 landed on heads. There were 12 total coin flips still. So that would be 9 over 12, which is also known as 3/4, or 75%. Another way you could figure that out is, since it's not tails, it must be heads, right? And if 25% was heads, then if 25% was tails, then the other 75% must have been heads. So that's another way you can kind of figure that one out as well, if you were asked that follow-up question. Okay. You get to try this time. 6 of the last 18 customers ordered a McDouble. That's a thing, right? McDouble sounds like a thing. Anyways, we're just making this up as we go. 6 of the last 18 customers ordered a McDouble. What is the experimental probability of ordering a McDouble? All right, you know what to do. Pause the video real quick, give it a try, then hit play again, and we'll talk about it. All right, hopefully you did that. 6 of the last 18 customers ordered a McDouble, so that would be 6 McDoubles over 18 total customers. This does reduce. These are both divisible by 6. So 6 divided by 6 is 1. 18 divided by 6 is 3. This is the same as 1/3 of the customers ordering a McDouble. That's the probability there. So if we were to divide this in a calculator to get our percentage, that's the same as 33.3%. All right, and that's it. We've got, let's see, quick recap. We talked about sample spaces and kind of our list of all the possible outcomes. We talked about theoretical probability, which is kind of our calculated probability. It's that number of total or number of favorable outcomes divided by the number of total outcomes. And then lastly, we talked about experimental probability, which is based on a series of experiments. It's the number of favorable outcomes that have happened over the number of total outcomes that have happened so far. All right, hopefully this was helpful. Go ahead and get started on your homework. Have a good one.